Hello students, in this week's video we're going to do differentiation of logarithmic functions. So do get ready a pen and some papers and practice along with me. So are you ready? Let's look at some concepts that are needed. To find the derivative of ln x is just basically 1 over x. And the derivative tends to be very large values for x near 0 and tends to 0. That means if your value of x is very big, okay, your derivative 1 over something very big tends to become 0. And if you have the values of x which is very near to 0, then your derivative will become very big, because 1 divided by something very small will give you a big value. Right, so for logarithmic functions, if you're asked to differentiate y equals to ln x will be just 1 over x. If it's ln u, it's basically just differentiating, just getting 1 over u, then times the u over the x. So for example, if I'm going to let u to be ax plus b, right, basically the derivative of ln bracket ax plus b will just be 1 over ax plus b times the derivative of ax plus b. And the derivative of ax plus b will just give you a. And with that, you have a multiplied with the numerator 1 will give you a over ax plus b. That explains what we have here. And for logarithmic functions, before we find the derivative, right, it's always a good practice to apply any of these three laws here to simplify the logarithmic functions. Right, so basically let's quickly go through the law. If you have log AB, ln AB, there will be ln A plus ln B, and ln A divided by B, that will give you ln A minus ln B. And if you have ln A to the power B, that will give you B ln A. And another thing to take note is ln A is just basically log base E. And if you have ln E, that's basically just log base EE, that gives you 1. So these are the concepts that are necessary before we solved problem sums involving differentiations of logarithmic functions. Let's look at the first question. So we're asked to differentiate 3x times ln square root x squared minus 2x minus 3. Before we jump in to use the product rule, we should try to simplify this first. How do we simplify it? We can actually write square root x squared minus 2x minus 3 in index form, and then apply the power law. Right, so you can bring the half to the front, and then with that I can multiply it with 3x, okay, to get 3 over 2x ln x squared minus 2x minus 3. Then the next step is I can differentiate that by using the product rule. We can let u to be 3 over 2x, v. So when u is equal to 3 over 2x, the u over the x will be just 3 over 2. And we can let v equals to ln bracket x squared minus 2x minus 3. And dv over dx basically will just be 1 over the denominator, then times differentiation of your whatever is inside the bracket, that will give us 2x minus 2. Then you just put them into one single fraction. Right, so the next step is write down the formula for the product rule, and you just substitute in your u dv over dx plus v du over dx. Okay. All right, so this we can just combine them into a single fraction, just multiply numerator and denominator. And likewise, okay, this part here that we're going to simplify it further. How do we simplify further? Yes, we're going to break 3 over 2 as 3 times half. The purpose of doing that is to make so that this half, I can apply the power law again, right? Put it back as radical form, right? That will gives you 3 times ln, yes, that will gives you, when you bring the half up, it becomes ln bracket x squared minus 2x minus 3 to the power half, and that is square root x squared minus 2x minus 3. Okay, so that is how we do it for the question 1a. Okay, so for this questions 1b, likewise, we're going to apply the logarithmic rules first before we differentiate it. Right, so we're going to apply the quotient rule. What is quotient rule? If you have ln bracket a divided by b, that gives you ln a minus ln b. So here we have ln bracket x plus 2 to the power of 3 cosine 3x minus ln sine x. And this, we can apply the product rule. Which product rule am I talking about? It's not the product rule for the differentiation, but the product rule for your ln AB. That will give you ln A plus ln B. So I can break it up into ln bracket x plus 2 to the power of 3 plus ln cos 3x, then minus ln sine x. And this I can further apply the power law by bringing the 3 to the front. Alright, so for the differentiations of the logarithmic functions, alright, we need to simplify whatever expressions were given using the laws that we have learned in the logarithmic functions. Okay, so at this juncture here, there's nothing much we can simplify anymore, so we're just going to differentiate it. Alright, so differentiate the first term. So this will give us, just leave 3 alone. Okay, just leave 3 alone. If we differentiate this, we'll get 1 over x plus 2, then times 3. And then ln 3x will be 1 over 3x. And then when you, this is a 3 steps thing. Okay, when you differentiate ln 3x, it's a 3 steps. The first step is you differentiate ln cos 3x, which is just 1 over cos 3x, times you differentiate cos 3x, that gives you negative sine 3x, and then you times the differentiation of, there's no bracket there, but you can just put a bracket there to remind you that you just still have to differentiate whatever is inside the bracket, which is 3x. You differentiate 3x, you get 3. Okay, so for ln sine x, it's just basically 1 over sine x, then times differentiation of sine x gives you cos x. Okay, so you have to be careful, right? Then we just simplify further. Right, so how do I get tangent 3x here? Because sine 3x over cos 3x will give you tangent 3x. And cos x over sine x will give you cotangent x. Okay. Right, let's look at question 2. So for question 2, we're given a curve that is y equals to x ln x, and then that's a particular point P that lies on the curve. And at point P, we can have a tangent line, and this tangent line is parallel to the line y equals to 2x minus 3. So if we're going to use a diagram to illustrate all this thing, this is what it means. Okay, I have a curve and the tangent line at the particular point P, all right, and that line has the same gradient as y equals to 2x minus 3. All right, so I need to differentiate y respect to x to find my dy dx. That is my gradient function. Well, I'm going to let this dy dx equals to 2. Right, so for the first step, I need to differentiate y equals to x ln x respect to x. So I'm going to use the product rule, let x to be u, ln x to be b, and then plug into the product rule. Okay, so this ln x plus 1 is going to be equals to 2, because these two lines that you have seen on the screen are parallel to each other. And we'll end up getting ln x equals to 1. And ln is just log base e. Okay, and from here, okay, this is called the logarithmic form. We're just going to convert it to index form. So this will be your base. Your base is base e. So x will be just e to the power 1. Another way of doing it is you just make 1 as log base e, and then you just cancel your log base e on both sides. So you end up getting x equals to 1. Alright, so we asked to find the coordinates of P, meaning I also need to find the y coordinates. So when x is equals to e, you just substitute into your curve. You have e ln e, and e ln e. Ln e is actually equals to 1 because ln is just log base e. So ln e is basically just log base e, and that gives you 1. So y equals to e. Therefore, the coordinates of point P will just be e comma e. Right, let's look at part 2. So part 2, we are told that the normal to the curve at point P meets the line y equals to 2x minus 3 at point Q. So what does it mean? If you're going to use a diagram to illustrate it, it means that earlier on we have a curve and a point P, and then we have a tangent line, right? So the normal line will be perpendicular to your tangent line. Okay, so this is your normal line. And this normal line actually meets the line y equals to 2x minus 3 at point Q. Alright, so this is what it means. So what we need to do is to find the equations of your normal line. Solve it simultaneously with y equals to 2x minus 3 to find our point Q. Our point Q is actually the intersection point of the normal line and y equals to 2x minus 3. Alright, so to find the equations of the normal line, I need to find the gradient. Right, so we are told that the tangent line, the gradient of the tangent line is 2. So the gradient of the normal line will be negative 1 divided by 2 gives you negative half. Okay, and we need to use point P because your normal line also passes through point P. So point P, its x coordinate is E, y coordinate is also E. Right, so therefore you have y minus E equals to negative half bracket x minus E. Simplified it, you will end up getting y equals to negative half x plus 3 over 2e. So we call that equation 1. We're going to solve it simultaneously with y equals to 2x minus 3. That's equation 2. Right, and then we're going to put all the x together. And you will have x equals to 3/5 bracket e plus 2. You're going to compare it with what you're given here, because you're given the x coordinate of q to be k bracket x e plus 2. You're going to compare it with that, and you will see that k is actually 3/5, which is the value that you're asked to find in the questions. Alright, let's look at the next question. So the next question is you're given a curve, but in this case here, you're given y equals to ln x over x. And x must be positive. Alright, x cannot be 0 because you can't have 1 divided by 0. Anything divided by 0 is undefined. So we ask to find the set of values of x for which y is an increasing function. So the concept involved here is when y is an increasing function, it means your dy dx has to be more than 0. Alright, so if y is a decreasing function, then dy dx is less than 0. So this is a concept involved here. We're going to use quotient rule to find our dy dx. Okay, so you differentiate ln x, you get 1 over x. Differentiate x, you get 1. Apply, put it in your quotient rule. By now, you should be able to remember the quotient rule very well. Plug in all your b du over dx, your u db over dx, and then simplify it. Okay, so how do we go about letting that equals to be more than 0? Okay, so first of all, yes, so like what I've mentioned earlier on, for increasing functions of x, increasing functions of y, not x, sorry, for increasing functions of y, your dy dx is more than 0. Alright, so that means 1 minus ln x over x squared must be more than 0. Alright, so observe that your denominator is x squared, so x squared is more than 0. It cannot be equal to 0 like what I've said earlier on. So x is more than 0, so therefore x squared will be more than 0. So to get a positive value, the final product must be a positive value. So if your denominator is positive, your numerator also must be positive. That means 1 minus ln x has to be more than 0. Alright, so we're going to find our x. We are solving inequality, which is different from solving an equation. So we need to find the x-intercept first. So we're going to let it equals to 0 first to find our x-intercept. okay, which is x equals to e. Okay, we're going to sketch the curve, right? This is how your curve would looks like. Okay, so for your curve to be above, to be positive, means we're actually looking at this part of our curve, the one that highlighted in blue. So for that value, our x will have to be between 0 and e. Okay, so this is how we solve question 3. Right, so for question 4 is actually related to connected rate of change. All right. So you're given that you have a curve y equals to ln bracket 3x minus 1. You're given that the y coordinate is increasing at the constant rate of 0.06 units per second. Right, so to put that in mathematical terms, it means you're given dy over dx equals to 0.06. And then you're asked to find the rate at which the x coordinate is increasing. That means you're finding the x over dt. All right, so we need to find dy over dx first. Okay, which you need to differentiate ln bracket 3x minus 1. That will give us 1 over 3x minus 1 times differentiation over 3x minus 1, which gives us 3. All right, so this is what you get. So at x equals to 7, your dy over dx will just be 3 over 20. Then you're given dy over dt to be 0.06. That's form the connected rate of change for the x over dt. All right, putting your dy over dt to be 0.06. And I need to flip this guy because what I need to substitute is the x over dy, not the other way around. So I will have to flip it to get 20 over 3. And that ends up getting 0.4. So if answer in proper English, the rate of change of x will be 0.4 units per second. Right, let's look at question 5. Question 5, the concepts are similar to question 4, except that in this, the curve given to you is slightly more complicated, where you need to use quotient rule. So we're going to let ln x be u, 2x plus 3 be v. Let's find the u over the x, which is just 1 over x. The v over the x is just 2. Plug into your quotient rule. All right. So you see that we have a fraction here. So I'm just going to multiply every term at the numerator with x. And also the denominator with x. So this is how I end up. Your 1 over x times x will just give you 1. So you're only left with 2x plus 3. And then 2 ln x times x will give you 2x ln x. And of course, the denominator will just be x bracket 2x plus 3 cross bracket to power of 2. So that is your dy over dx. So for part 2, all right, we're going to substitute. Oh yes, we're given that y is changing at the rate of 0.12 units per second. And then at x equals to 1, we're going to find our dy over dx, which is 1/5. And then we need to find the x over dt. So that's form the connected rate of change for it. I will need to flip my dy over dx because from the connected rate of change, I'm actually multiplying with the x over dy. That gives us 5 over 1. So 0.12 times 5 will give you 0.6. Therefore, the rate of change of x will be 0.6 units per second. Right, let's look at the second last question. The second last question has 3 parts. The first part is just to find the y dx at point Q. But if you look at point Q, we know that the y coordinates is equals to 0. And you're not given the x coordinates. So we will need to let y equals to 0 to find my x coordinate. But before we do that, let's find the gradient function first. Let's find the y dx first using our product rule. So I'm going to let x squared be u, ln x be v. So the u over the x will just be 2x. The v over the x will be just 1 over x. Plug into your product rule, you will get 2x ln x plus x. And the next step is at point Q, I need to find my x coordinate to substitute into my dy over dx. Right, so I'm going to let x squared ln x equals to 0. And it's either x squared equals to 0 or ln x equals to 0. But if you look at point Q, definitely x is not equal to 0. So we're going to reject that value. We're going to use ln x equals to 0. So ln is just log base e. So log base e x equals to 0. So if you convert to index form, it means x is equals to e to the power of 0. E to the power of 0 is 1. So with x equals to 1, I can now substitute into my dy over dx, which is this expression here, to find my value for dy over dx. Okay, which give me 1. Because ln give me 1. Okay, right. Alright, so for part 2, we need to show the x coordinates of point P. It's 1 over square root E. Right, if you look at point E, you are told that it is a minimum point. Point P is a minimum point. So if you were to draw a tangent line, that means the gradient of that tangent line is 0. Right, so we're going to let dy over dx equals to 0. So in part I, we found our dy over dx to be x ln x plus x. So that equals to 0. Factorize a common factor x out. So it's x equals to 0, which we're going to reject it again because the x coordinate of P definitely is not 0. Alright, and then from here you can just have 2 ln x equals to negative 1. So ln x is equals to negative half, and ln is just log base e. So log base e x equals to negative half, x is equals to e to the power negative half, which is just 1 over e to the power of half, which is just 1 over square root e, which is what I have here, which is what you're supposed to show. Right, so for part 3, we're supposed to find the squared y over the x squared at point P. Right, so from part 2, we have found the y over the x to be 2x ln x plus x. So the squared y over the x squared basically is just to differentiate the dy over the x. So to do that, here I'm going to apply product rule. Right, so we let this be u, this be v, and this one is quite easy. Differentiate x, you just get 1. Okay, so this is what I end up with, du over dx. The formula will be u dv over dx, right, which is 2x, and then differentiate ln x, you get 1 over x plus v, which is ln x, differentiate 2x, you get 2. 10 plus x, differentiate x, you get 1. So this is what I get for d squared y over the x squared. You simplify it further, okay, by substituting in x to be 1 over square root e, because you asked to find the value. Alright, so we substitute x to be 1 over square root e, which I found earlier in part 2. This and this goes off. So you end up getting, okay, here what I've done is I have rewrite this as 1 over e to the power of half, which give me e to the power negative half. Why do I want to do that? Because I want to apply the power law to bring your negative half to the front. And this is what I've explained earlier. This and this goes off, so left only 2. And the negative half, if you were to apply power law, bring it to the front, it will end up negative half times 2 ln e plus 1, and ln e is 1. So you have times 2 times 1, that gives you half times 2 times 1, that gives you 1. So 2 minus 1 plus 1 will gives you 2. So that is the value for d squared y over the x squared. Right, let's look at the last questions. So the last questions, you're given v equals to lambda x squared ln to 1 over x. Right, lambda is actually a constant, so it could be just any positive value like 1, 2, 3, 4, 5, whatever. Okay, it's a constant. Alright, so we will have to, you're told that this speed is a maximum. Right, so when you're told that y is a maximum, y is a minimum, means dy over dx equals to 0. So if v is a maximum speed, what we are saying is dv over dx will be equals to 0. Right, so I need to differentiate v respect to x using the product rule. Okay, so I'm going to let this equals to u. Right, so lambda is a constant, it's just like a number 2 or 3 or whatever, just ignore it. You just need to differentiate x squared to give you 2x. So du over dx is lambda 2x. And then what I've done here is I have rewritten ln 1 over x as x to the power negative 1, so I can apply the power law to get negative ln x. So that when I differentiate it, it's just negative 1 over x. Okay, and then I put it into my product rule. Right, simplified it. I can actually simplify it further because this x squared and x will just give me x, so I will end up getting negative lambda x plus whatever we have here. All right, so I'm going to equate that equals to 0, where I can just factorize lambda x out. Okay, and lambda x equals to 0 is to be rejected. Why? Because then I will have x equals to 0 divided by lambda, who gives you x equal to 0, but x is between 0 and 1, so therefore I need to reject the value. So I would have negative 1 plus ln 1 over x times 2 equals to 0. Okay, you can simplify it further. Right, and then you can, how do I get that? Because ln is just basically log base e. So x to the power of negative 1 is just e to the power half. And x to the power negative is 1 over x. Alright, so just flip it. 1 over x, you flip it, you get x. E to the power of half over 1, flip it, you get 1 over e to the power half. So that's explain how I get this answer. How I explained, that explain how I get x equals to 1 over e to the power half, and e to the power half is square root e. Okay, so this is how you do for the last questions. It's not difficult at all.